All right, guys, in this brief video on chapter 4, we're going to just cover section 1 real quick. We're going to talk about the development of what we call the force concept. It's something we're going to come back to over and over and over again. Just so you know, our whole idea or our whole goal in this particular section is to define what a force is. In fact, we've already kind of talked about forces in that we define them really simply as a push or a pull. And since a push or a pull has both magnitude and direction, I pushed the box 4 meters to the west, then we can also describe it as a vector quantity. What we're studying right now is still dynamics. We've been studying this since the beginning. We studied a subcategory of dynamics referred to as kinematics, which is specifically how things move in X and Y dimensions. For now, we're going to move on to understanding how forces work in the terms of vectors. So now, instead of just drawing vectors to represent displacement or velocity or acceleration, we can draw them to represent more generic versions of those quantities referred to as forces. And here we can see that a combination of forces drawn into one diagram, force 1 and force 2, if you add those two forces together, we get that resultant force of total force that you see on this particular diagram. Force will always be an interaction between two or more objects. Now, no specific object possesses a force on its own, but they can put force onto another object. So to kind of think about this, we can think about how a cannon doesn't actually possess the force, but it can actually exert a force on a cannonball when energy is inserted. Earth does not possess its own force, but it can exert force on any object known as gravity. And then we talk about a very important type of diagram called a free body diagram. This is going to be something that we use to identify all of the forces that can be acting on a single body. We use a single point to represent that body. That point can represent a planet, it can represent a person, it can represent a car, it can represent any individual location in space where something is occurring. And then everything that is happening to that body can be drawn as vectors extending from the body. Now, in the particular example of the skaters that we see in this chapter, one of the things that we want to know is that just pretend, and I would say let's ignore any internal forces that might be going on within the body. So in reality, inside of your body, there's forces that are moving food through your system, and there's forces that are pumping blood from your heart to your extremities and the back. We're going to ignore those specific forces within that body. We're only going to look at the ones that are externally acting on the specific body we're discussing. And a body is a misnomer. I don't mean a person. I just mean any object. These free body diagrams are going to be really useful for us so that we can analyze what we call Newton's laws of motion. So this is the initial concept of how we can get to Newton's laws of motion. You're going to be reading over sections 2 and 3, Newton's first and second laws of motion. But for now, just to kind of go back over it, a force is anything that is a push or a pull, like we said. We can have forces that are referred to as restoring forces, and this is really common with a spring, where when we extend the spring, the force required to restore the spring to its original position is referred to as a restoring force. Other types of forces that we will end up talking about in depth are things like friction forces, which oppose the direction of motion. We will talk about normal forces, which are always present. We'll talk about gravitational forces too as well. For now, that's really it. That's all we want to talk about with section 1. Like I said, it's a very short video. I want to make sure that we understand exactly what a force is, and then we are going to work with free body diagrams in the very near future. And we'll start when we discuss Newton's first law of motion, which for now, I'd like you to go and finish your reading assignment, which is due tomorrow. All right, that's all I have for you today. Have a great day.